Okay, let's get started, y'all. Hope you had a good Labor Day weekend and you're all nice and relaxed. Got any work done that you needed to? A quick reminder that your first homework assignment is due this Friday at 6 a.m. What that really means is that it's due Thursday night and that you should make sure that it's done before you go to bed Thursday night. Now, if that happens to be Friday morning at 4 a.m., that's fine. Just 6 a.m. is the due date. You can hand it in up to 3 days late. There's a 10-point penalty for each day late that you do. So if you hand it in 3 days late, the highest you could get would be a 7-day. Also, the homework solutions are released 3 days after the homework is due. There's a link on Blackboard called Homework Solutions. If you go to that, then on September 12th at 6 a.m., you can view the solutions for Homework 1. So those are useful for studying for the exam. You should have watched the video for joins updates on Thursday or sometime over the weekend. Were there any questions about that? Everyone pretty comfortable with joins and updates? Okay. So today we are focused on two things. First of all, subqueries, which I showed you an example of a couple weeks ago as to how you can use them to essentially introduce an aggregate function into a where clause. And we'll see a couple more examples how you can use subqueries. And then we'll talk about the data definition language for SQL. So chapter 4 talked about the structure of the relational model. Chapter 7 is SQL's implementation of chapter 4. So chapter 4 was theory. Chapter 7 is the actual implementation. And I don't think we'll quite get through all the DDL stuff today, but that's okay because we have 2 days to go over the relational algebra and calculus, and I don't think it's going to take exactly 2 days. So we'll probably bleed over a little bit into Thursday with the DDL stuff. So we'll see how far we get. Okay. So you can accomplish much of what you need to do in SQL without subqueries. For the most part, they were introduced to provide syntactic sugar. Remember that end users are not computer savvy. They don't necessarily think the way that computer scientists think. And in particular, even as programmers, joins are a somewhat difficult idea, it seems, for a lot of people to wrap their heads around. They're kind of a mathematical concept, and you may find that you are more comfortable using subqueries to express queries that could be better, well, could be equally well expressed using joins. So we're going to go over the 3 different kinds of subqueries, and in many cases I'll show you how you can do the same thing with a join clause. So a subquery is simply a select statement with nested select statements. So here's an example of such a statement. So we're listing the staff who work in the branch at 163 Main Street. And one way to write it is this way, which is to say that we're selecting the staff where the branch number is equal to, and now we're selecting the branch number from branch where street is 163 Main Street. So what this is going to do, the innermost select statement is evaluated first, and it will return some branch number. Let's say that the number it returns is B002. So the result of that subquery is plugged in, and so now we're selecting from staff where the branch number is equal to B002. Okay. You may notice that I could also express this using a join. I could say select, and I'm just going to use a star right now so I don't have to write out all those things. Select star from staff natural join branch where street equals 163 Main Street. And that's the same query using a join. So I didn't need to use a subquery in this case. The two queries that you see there are equivalent. And as far as the homework goes, you're free to use either one. Although if I give you a query on an exam, you need to be able to understand both types of queries. And certainly, one type of question I might give you on an exam is, I want to list the staff who work in the branch at 163 Main Street. Which of the following queries satisfy this request? And in this case, both of those queries satisfy that request. So even if you don't feel particularly comfortable with joins, you need to be prepared to see a join and know how it works. Yes?
Is there a speed difference between those two methods?
So there shouldn't be, because a good query optimizer should be able to figure out how to do it. That in particular, whichever form is more efficient, the query optimizer should be able to translate to that form. So you shouldn't worry about efficiency. SQL is about expressing what you want, but not how to do it. So that's why I say on the homework, you should express it in the way that you're most comfortable. Okay, and don't worry about which is most efficient, because a good query optimizer should be able to do either of these equally efficiently. Yes?
Question about the exam. Just because I know someone will probably ask about it during class, so the ones where there may be more than one answer be marked that there may be more than one answer?
Yes.
Okay.
Yep. I've learned. Okay. So that's just showing the subquery resolution. So it's the same thing that I have here. The innermost query is evaluated first, and then it replaces, here it was B003, and then it gets substituted in, and then it solves the outermost query. Okay, and then here, what I just told you, that's replacing that subquery with a join. And again, whether I state it this way or using the syntactic sugar there, either way is fine. Yes, Jaja?
So for the subquery, will they return, like, do they have to return one outer or?
No, we're going to get to that. This is one of the three types. There's three types of subqueries. Okay? So this is called a scalar subquery because it returns exactly one value. But it's not the only type. We'll get, in fact, I think, there we go. Types of subqueries. So this is a scalar subquery. It returns a single value. And of the three types of subqueries, I think this is the only one where you sometimes absolutely need it because you can't occasionally use a join to express it. So with a scalar subquery, you can effectively insert an aggregate function into the where predicate. So you'll recall that you can't directly place an aggregate function in a where predicate. That will give you an error. But you can do it indirectly through a subquery. And here's an example of that. What I want is to list all staff whose salary is greater than the average salary and the amount by which they exceed the average. So in order to answer this query, I need to use an aggregate function, average. And the way I might like to be able to do it is simply say, select blah, 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 salary minus, and I'd like to just be able to say salary minus average salary, where salary greater than average salary. But I can't do that because I can't directly put aggregate functions like this into either an arithmetic computation or into a where predicate. But I can put them into subqueries. So here I am selecting the average salary from staff as salary difference, and that will return the average, and it will be subtracted from salary. And then I'm repeating the same subquery there, and again, that subquery right here will return the average salary for staff, and anyone that has a salary greater than it will appear in my final result. Yes?
Is there any way to slow it down from the first subquery so you don't have to call it twice?
Good question. So, yes, using something called SQL variables. So, using an SQL variable, you can store an intermediate scalar value. You can't store a table in an SQL variable, but you can store a scalar value. So I can here select at, so every SQL variable is prefaced with an at sign, average salary equal, you'll notice the colon here, colon equals, average salary from staff. So it is assigning the average, and now down here I'm saying salary minus at average salary, where salary greater than at average salary. So that's the way that you can store an intermediate value. And you can see that it's just like in the scripts that you used to create the hotel tables for homework 1, you just put them here in sequence. So it's just 2 in sequence. And again, it's really important because when I first started using SQL variables, more than once I made the mistake of trying to store a table into them, because you're going to find often you want to store a table as an intermediate result. If you do that, you actually can, you just have to use a view, which we'll get to. You can't, so SQL variables store scalars, views store tables. Yes?
If you did something like an update after that second select, and then you did the second select again, it'll still be the same thing because the variable's a value instead of a query?
Yes, so it won't reevaluate the query and assign and update it, so your average salary would now be wrong. Good question. Other questions? Okay. So, same idea with query resolution. If the average salary was $17,000, it ends up evaluating those subqueries first, substituting 17,000 into both places, and then the outermost query is solved and you get your result. Okay, so then the second type of query is a row subquery. So Jaja, in answer to year 1, this one's going to have multiple rows. And this is the only type of subquery that's allowed to have multiple columns in the result, although you really don't make use of those multiple columns. So the only time you use a row subquery is in conjunction with something called an exists predicate. And That's simply asking exists is simply it returns true if the set of return. Remember, a relation is essentially a set of tuples. So if a set is non-empty, exists will return true. And if this set is empty, it will return false. So you use a row subquery to return a set. And then you're simply finding out whether something is in that set. So here, we're saying find all staff who work in a London branch office. And one way to do it is to essentially select all branches where the branch is the branch number is equal to the staff's branch number and the city is equal to London. So essentially, this is returning a tuple if the staff member belongs to a branch in London, and it's returning no tuple otherwise. So this subquery right here is really going to return, it returns either no tuples or one tuple. Now this is assuming that each staff member can work at exactly one branch. If a staff member were allowed to work at multiple branches, it could return multiple tuples. And a row subquery could return multiple rows. But in this case, we limit each staff to one branch, so it's going to either return no tuples or one tuple. So basically, the exist clause is going to return true if the staff member is in a London branch, and otherwise it's going to return false. So essentially, what happens is for every tuple in staff, it is checking to see whether that staff member has a branch office in London. Yes, Jojo.
Why do you not have to include the staff table inside of the subquery?
Why do I not have to include what?
The staff table, like from branch B and staff C and C. Again, inside the subquery, you said from branch, but
So right here, right, this S, is that what you're saying I'm referring? So in a subquery, you're allowed to refer to a relation in the outer query. So that's what I'm doing here. It's like scope. You know how in a like for statement, you can, in a for loop, you could have int x, and then you could have for I equals 0, blah, blah, blah. And then in here, x is defined, even though you're inside this is defining an inner scope. So same idea. So that's why I don't have to refer to the staff in there. In fact, it would be a mistake because if I did, it would mask, just like a variable declaration in here would mask the outer x. If I actually said select star from branch B, staff S, then this S is going to refer to any tuple in S rather than specifically to the tuple that was selected from that one, and you'll get a different result. Okay, so in fact it would be bad to put this right here. It would actually ruin your query. Other questions? Yes, Sean.
why don't we have a d.c equal London right
Have a what equal?
there? Like when where branch number equals to branch number and C
Mm-hmm.
is London, why don't we do d.c branch?
Because city in this case is unique. There's no, the question was why don't we preface this with b.city? And you could, but there's no ambiguity because city is not an attribute in the staff relation. It's only an attribute in the branch relation. Whereas here, there is ambiguity because branch number is duplicated. So if you want to be really like safe, especially for future people, you would always put a B dot in front of it, because if someone later changed the structure of the staff relation to include a city, then this query all of a sudden would not compile any longer. So if you're actually looking down the road toward maintenance, which most code goes into production, you would actually preface everything. Other questions?
Why you will return no tuples or one tuple? Will it return multiple tuples?
Okay, so the question is, why will it return either no tuples or one tuple? Because a staff member can work in exactly one branch. That's a constraint on this particular database. So it's impossible, given a specific staff member, which is what you have down here, that staff member will always only have one branch number, and therefore it will that branch will either be in London, in which case we'll get one tuple back, or the branch will not be in London, in which case we'll get 0 tuples. So as I said, if I relaxed the constraint and said it was okay for an employee to work in multiple branches, then it could actually end up returning multiple tuples. Other questions? Okay, I'll be honest, I don't find this at all intuitive. And you can write the same, just a second, nope. You can write the same query here as a join. So you could have alternatively written select, and again I'm just going to say star so I don't have to write everything else, from staff S natural join branch B where city equals London. Okay, and that's the same query. And it's a lot more succinct. So for me at least, I understand the second query. I find it much more understandable than the first query, but you might not. You might find the first query to be more understandable. Now, I could also on a test give you the first query and tell you you have to rewrite it as a join. So you do have to be able to, on an exam, write joins for me. I won't, even if on the homework you prefer to use subqueries, on an exam you need to be able to write queries involving joins. Yes?
On the exam, would we have to use like the join keyword, or could we do it to something?
Either way, you won't have to use the join keyword. In fact, as I told someone after class last time, the reason you rarely see me use the join keyword is I'm old school, and they didn't, initially the way you wrote joins was with this syntax, and I'm still kind of in that. I have to struggle to actually remember to use the syntactic sugar. So either way is fine. Okay. Other questions? Okay. So we have so far seen a scalar subquery which returns one value. We've seen a row subquery which returns multiple rows and possibly multiple columns, but you only can use it in a very restricted situation. The final type of subquery, so this is number 3, is a table subquery. It actually, I wish the book had called it a set subquery, because what it's really doing is returning a set of values for a single column. So the row subquery could return multiple columns. The table subquery, it returns a table suitable for use within. If you remember, in is essentially just asking if a value is in a set of values. So essentially, the table subquery is simply saying really returns a set of values. Okay, so here's the example of listing the properties that are handled by staff who work in the branch at 163 Main Street. And this is a subquery nested in a subquery, nested in a subquery. So this would be the first one evaluated, this would be second, this one would be third. Okay, this one is a scalar because it's just returning the branch number. This one is my table subquery. So this one gets evaluated first. It returns, we'll say B003. Then the second one is returning, it really returns the set of staff numbers in branch B003. So what we're really doing is saying select any property, so that's what this is, select any property from property for rent where staff number, so now staff number, there is a staff number in property for rent. Okay, and that is the number of the realtor who manages that property. And there's no ambiguity here because there's only one relation in the outer query. That's property for rent. So it's saying where the realtor who manages this property is in the set of staff numbers in branch B003. So that's essentially what is being asked for here. Okay, now it is true that staff number is duplicated here, but because the only relation in this outer query is this one, there is no ambiguity as to what this staff number is. Okay, so that's your table subquery. Yes, probably. Let's see.
Yeah, because there's two left.
Yeah, it looks like this parentheses is not matched off. Yep, very good. Other questions, comments? Now again, this is pretty involved to me, and you can express it more succinctly with a join. So in this case, I can say select, again I'll say star, from property for rent. P, natural join, staff, natural join, branch, B, staff S, where street, and probably now you have to say B dot street because there's a good chance that, yes, in fact there is, that's property street, this is branch street, so there's a conflict. B dot street equals 163 Main Street. Okay, that's the same query. So two joins, and then just saying where B dot street equals 163 Main Street. And it returns the same set of tuples in a much more succinct query. But again, for many non-computer programmers and for many of you, this query here will seem more natural than this query. So as I say on the homework, use either, but on an exam, I expect you to be able to write the joins. Okay? I'll actually be honest. The only type of subquery I would expect you to write on an exam would be a scalar subquery that is required with an aggregate function. So I might say select the name of the person with the minimum GPA. In that case, you're going to have to use a scalar subquery. There's just no way around it. But that's the only type of query I would ask you to write on an exam. Okay? So questions about subqueries? Okay? So just a few rules. You can't use an order by clause in a subquery. I mean, why would you? The subquery is not going to be printed out. So there's really no reason to tell it to order its result. In general, you can only return a single column from a subquery unless you're using the row subquery, and in that case, it can only be used with an exist predicate. Okay, John Senior, this was kind of the question you were asking. So by default, column names in a subquery refer to the table name in the from clause of the subquery. So if you, that was where back here, this S dot branch number was actually referring to the S in the outer subquery. So that's what that one. And finally, when a subquery is involved, it has to be on the right-hand side. So this is not legal because the subquery is on the left-hand side. So that's just a syntactic rule that the subquery has to appear on the right-hand side if it appears in a predicate. Yes?
Do you know what the purpose of that rule is?
Absolutely not. Seems stupid. You'll hear me give strong opinions sometimes, and I just think that's stupid. Absolutely, as far as I can. Oh, and I misspelled from. I see. Yeah, there's absolutely. I can't imagine why there would be that. To make someone's life easier, to make it easier to write the context-free grammar that is required for this. Thanks for asking so I can rant, because I've always thought it was stupid. But that's the only thing I can think of, is it made it easier on the person who wrote the context-free grammar. Other questions? Okay. By the way, I also think it's rather dumb that you can't include aggregate functions directly in where predicates. I don't see any reason why they shouldn't be allowed in where predicates, but again, wasn't up to me. Okay. Sure. Just take a moment and see. I'll give you about 4 to 5 minutes. See if you can't list all guests currently staying at the Grosvenor Hotel just using subqueries, which means that your query will begin like this. Select, I'll just say guest, don't worry, guest name from guest, G, where. So now try to write this query. See if you can't do it using subqueries. I'd never ask you this on an exam, but I've covered it, so take a couple minutes and see if you can do it. Remember that you can use curDate to determine what the current date is, because currently staying means that you need to know the current date. Yes?
If I think about it, allowing
subqueries to be on either side would allow you to do something in the join that you couldn't do in the joins other than aggregate functions. Because you could actually compare the result. You could actually use it to compare the results of subqueries.
Okay. You could have an restriction that says you can't have subqueries on both sides.
Yeah, that's really weird.
Right, so you're trying to figure out how convenient on the way you take the
Probably an arbitrary decision to make it a lot less messy.
Right.
Again, from the context-free grammar. Because that would be really messy. To use the grammar to enforce that restriction, and you know, you could only have one on one side.
Right. That's
Just arbitrarily.
That was probably so possibly it's more sensitive. You would try to enforce the restriction that there be only one subquery. Instead, you would parse it and then you would check after the parsing to see whether there was more than just one sub. Well, issue. That's all. If you say in X and you string Y, and say Y as context free, then type checking was correct. That's all it context is sensitive. So I don't know if you take
That was read so expecting to be much more difficult.
312 might also
Gets into a numeric turn machine, though.
As it should.
Yes, this bit turn machine turn what it likes to call it A. This one is A. Might as well shoot for the stars.
There you
If you miss, you'll hit the moon. I mean, the moon had to come to.
How many people need more time? Couple? Okay, I'll give you another minute or two. Yeah, you can actually do it if you have your computer. In past semesters, the homework's been a little later, so all I did was change 2015 to 2016, so this may be a little early.
Yeah, I never actually tested my one where you had to select the correct dates because, yeah, it's obviously going to return it. But it should work. I'm confident it
Yeah. When I was in graduate school,
But you said it right.
it was
So that's why.
Okay, so let me tell you how you should think about it if you were doing this as a subquery, which I never would, just an editorial aside. But so select guest name. Okay, I'm sorry, list all guests currently staying at the Grosvenor Hotel. So what you need to kind of get your mind around is that it's going to be in one of the set of bookings for today, where so you're basically it's going to somehow be where the guest number is in some set of bookings. Okay, the set of bookings. You probably need a G, yeah. No, you don't. Because there's only one relation here, so there's no ambiguity. Inside the inner query there could be, but in the outer query there's no ambiguity. So where the guest number is in the set of bookings that are, I'll say, active, meaning someone's staying, and are associated with the Grosvenor Hotel. So you're going to need a table query here, because this is looking like a table query in a set. So we select star from guest where guest number in. So we're selecting guest number from booking where the current date is between date from and date to. Okay, and the between clause works quite nicely because you can compare dates like they're numbers. And then I used a scalar query for the Grosvenor Hotel to select the hotel number from hotel where hotel name equals Grosvenor Hotel. So I am getting the set of bookings that are active today and associated with the Grosvenor Hotel. So that is the way that you could write this particular query. So questions about that?
Why do you have to use in?
Okay, so I had to use in because it needed to be, if I go back to here, what I need is that the guest number be among the set of bookings that we have with the Grosvenor Hotel today. So it has to be in that set. So the way we write, so I need a table query, and this just happens to be the syntax for a table query. You use in.
So equal won't work?
Equal will not work, yes. Okay, that's the question. No, equal will not work in this case. Because what you're saying then is it's equal to the set. It's not equal to the set, right? It's one of. There could be 10 bookings in that set. So if you tried to say 1 is equal to 10, it doesn't make sense. So that's why you say 1 in. Okay, yes?
Does it between the last date also?
Yes. So the way I said that date 2, if you look at my homework assignment, it says date 2 is only up to the date. In the homework assignment, I said if you have something that's like 8/13/2016 to 8/17/2016, it's literally those dates. And so between is saying less than equal.
Yeah, but shouldn't it just be less than?
No.
That's what it says in the homework, doesn't it, though?
No, it says that in the homework assignment, it says the booking ends, the date 2 column, on the last night the guest occupies the room, not the day they check out. So if the guest checks in on August 8th and checks out on August 12th, the date from will be August 8th and the date 2 will be August 11th. So it has to be less than or equal to.
Okay.
I did this because to make your life easier, because if I had allowed it to be 8/13, say 2016, oh wait, let's do it on these. If I'd allowed it to be 8/8 to 8/12 as the checkout, okay, and then someone else had as a check-in 8/12/2016 to say 8/19/2016, you would double count this room because you would think that it was both occupied by the person leaving it and the person coming in. It would have been a lot harder to write that query. So that's why I was so careful to write that there.
Yeah, I misunderstood it. I thought date 2 was August 12th.
Mm-hmm.
Not August 11th.
Yep. That's specifically why I did that, to make it crystal clear, or else you would be in a world of hurt. It would be a lot harder to write that query to eliminate that problem. Yes, Jaja?
So for both dates, it will be less equal to. and
Yes.
greater.
Well, it would be greater than or equal to date from and less than or equal to date to. Yes, both of them. Yes, that's what between is. Between includes it. So it's like greater than equal and less than equal.
Not according to the dictionary, but according to
Yes.
So for
And that rules. Yes.
So for that question, like I think I did the same thing he did, where I did like greater than or equal to and less than to cut off that there, but it should be greater than or equal to and less than or equal to.
Yes. Believe me, it makes it a lot, like I said, otherwise you could not eliminate the this problem I have up there where you have two rooms. Because try to write that query then and say, what are you going to say? Well, if you try to say it's only if it's greater than or equal to date from and less than date to, it's not going to pick up everything. So you can do it by hand. Other questions? Okay. Moving on. The DDL for SQL. So I am going to blow through this fairly quickly because, believe me, it's boring otherwise, and you can read just as well as I can. One of the skills you need to have as you come out of this program is the ability to read documentation. And having me read documentation to you is one of the most boring things I can imagine that I could do. So I will let you look at the slides on your own time and at your leisure. I will just point out the most interesting things about the syntax on the slides. Okay? So the main things we're going to talk about is how you create and change tables, how you specify integrity constraints on the data, and how you define and maintain views, which is what Chapter 4 was about when it talked about the relational model. So SQL gives you a bunch of handy-dandy types, and there are, again, I'll let you read them, but here's the interesting things. Boolean is actually tri-valued, not dual-valued. There's a third truth value, which is null, simply means unknown. Okay, it doesn't mean true, it doesn't mean false, it just means unknown. Okay, character data has two different types, fixed size and variable size. Each has an advantage. Fixed size takes up more space but is far more efficient because just like an array, the way you get fast addressing in arrays is knowing that each array element takes up a fixed amount of storage, so array addressing is fast. If arrays could have variable size contents, it would be a lot harder to access an array. In fact, you would almost have to do a linear search. So having fixed size fields tends to be the most efficient time-wise. And generally, you would want to go with fixed width fields. Now, you can go with varchars if you want. That means it's variable length, and it will only use the number of characters that is actually required. With the fixed length, any extra characters are padded with some kind of fill, typically spaces. Okay? With numeric data, you can represent numbers either precisely or imprecisely. Typically, in programs to this point, you have not cared about the inability to represent numbers precisely. However, in financial transactions, even a difference of a thousandth of a cent over thousands of transactions can mean thousands of dollars. And so for financial transactions, you want absolute accuracy. So SQL databases give you the option with numeric data to represent it either precisely or imprecisely. Precisely, you use either the numeric or decimal keywords. They're identical. They literally are identical according to the standard. And you specify both the number of digits and the number of decimal digits. So decimal 7, 2 means 7 total digits, 2 decimal digits. So up to $99,999.99. Imprecise numbers are like C and C++, and just like C and C++, you can either use a float or a double. So it's okay if you don't need it absolutely precise. Okay, and again, you can specify the total number of digits and the number of decimal digits. Using either type of data, you can perform numeric operations on either type of data. Obviously, with financial transactions, we need to perform numeric operations. However, the difference is that approximate numeric data can be stored much more compactly. Does anyone know why? Does anyone know what would be the most reasonable way to store a precise numeric data? Yes?
Binary coded decimal?
Yes. So basically, I call it packed decimal. So usually you would store it you can get 2 numbers per byte because a number is takes up to 4 bits, so you can get 2 numbers into a byte if you represent them using 4 bits. So we used to call them packed. What did you just call it?
Binary coded decimal?
Binary what?
Binary coded decimal?
Binary coded decimal, which I believe is the same thing. I could be wrong. Don't correct me if it is, but the way I'm familiar with is what's called packed decimal. Okay, they claim that it's represented using actual characters. I'm dubious about that. I think that it's involving some kind of special form, but nonetheless, the difference is it takes more memory to store a 7-digit precise number. In my thing, it would take 3.5 bytes, whereas with a float or a double, you could do it in 4 or 8. Okay, so it's typically more space efficient to use a float or a double, but it's less precise. Okay, dates. You can specify dates. They are in a specific format, which is year, 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 then the month, then the day, separated by dashes. That's precise. Then there is time, which stores the time as hours, minutes, and seconds, and a timestamp, which is date and time. And what is really convenient is that there's a whole series of functions, you've already used current date, that allow you to either retrieve the current date, the current time, or do arithmetic on dates. So one thing that would be really useful often is knowing the number of days that a guest is staying with us at the hotel. And to do that, you'd really like to subtract date from date 2, right? But you can't actually write date 2 minus date from, because that's not an arithmetic operation. However, there's this cute thing, Datediff, and if you were to write Datediff, date 2, date from, that would automatically compute the difference, and you'd have the number of days that the customer stayed with us. Okay? Which is also why you would not store in the database, in the booking, you might think, well, why not also store the number of days the guest is staying with us? It's redundant information. You can compute it by calculating the difference between date from and date 2. And just like there's date diff, there's also time diff. Like if you ran a race and you want to know the winning time, you could just record when they started, when they finished, and do a time diff. Yes? Yep. If you swap those so that it's date from and comma date 2, it will return a negative number. Yes?
Do they have anything that allows you to, that can do both date and time difference?
I would have to look it up. So, before I came to class today, I looked up time diff, so I know there's time diff. My guess is yes, but I'm not 100% positive. Okay. You're welcome. Okay, so notice you can also add a specified time interval. So, in addition to dates and times, you have intervals. So, you might have 1 year and 3 months and 5 days. Or for a race time, you might have 10 minutes, 5 seconds. Okay? An interval is different than time. So time is meant to represent wall clock time. So this is supposed to be wall clock. Okay, which means you really shouldn't have anything over 24 hours. Actually, 23 hours, 59 minutes, and 59.9999 seconds. So time is supposed to be wall clock. That's different from a time interval. Okay? If I did a time diff, I get a time interval. I subtract my starting time from my ending time, I get a time interval, not a time. That's an important distinction. So there's a difference between an interval and time. Time is wall clock time. Interval is some interval of time. Okay? And you can specify it has different units: year, month, day, hour, minute, second. And again, I'll let you read it. But date diff and time diff will return intervals. Similarly, if you do a date add or date subtract, you add an interval to a date. So I could, for example, in booking, have used date from and number of days to stay, and then computed date to. Yes?
There is timestamp diff.
Okay, timestamp diff. So, very good. So, in fact, you can actually take 2 timestamps and subtract them. So, for example, if you're ultra marathoning, you could timestamp the start and finish. Okay, so remember, if you're manipulating dates or times, you do have these functions. You can easily Google them. Usually that's what I do. Okay, so basically that takes care of the types in SQL, or the interesting things about types. Okay, so then we have integrity constraints. And from the relational model, there weren't quite 5. There was null, there was entity, referential, and general constraints. And they add a fifth one, which is domain constraints for SQL. So number 2 here, this is in addition to the 4 that we had listed in chapter 4. So required data is whether a data field must contain a value. Okay, does anyone remember if it doesn't have to contain a value, what could be the alternative? No. So basically, 1 is saying, is the field allowed to contain no? Yes or no? 2 is limiting the set of legal values for a field. So for example, if gender, you may just want it to be male or female, or there may be another designation for someone who doesn't want to be identified in either category. Let's see. You might have just branch numbers. You might want it to be only the set of branch numbers that are currently assigned. You might want to say that a salary can only be between 0 and 100,000. So all of those are limiting the set of legal values for a field. Okay, we've talked about entity integrity and referential integrity and general constraints. So the question becomes, how do we define these in SQL? Okay, so here's the syntax for required data. And it's very simple. If you don't say not null, then by default you can have null. So you have to explicitly say not null if data is required. For domain constraints, there is a check clause that allows you to place constraints on the legal values. And you can, in a check clause, you can use anything that would appear in a where predicate. So anything that appears legally in a where predicate can appear in a check predicate. Okay. So it says check sex in MF, but I could also have something like check for salary. I could say check salary greater than equals 0 and salary, I know I could say between 2. So anything that's valid for a where clause is valid in a check clause. Okay, so you can also in SQL create new domains, which are basically like type diffs in C++ or enumerated types, either one. So here we're creating a new domain called sex type as a char, checking that its value is in either M or F. Okay, and then you can just use that as a new type. Okay, and this is just showing, this is creating a domain of branch numbers. Presumably we would use this for a foreign key. Remember, a foreign key must point to an existing key in another relation. So to ensure that, we might, for example, create the domain of branch numbers and check that its value is in the set of branch numbers defined in branch. So now we could use branch number as the type of any foreign key in another relation, such as in the staff relation. So now we can ensure that referential integrity, that every branch number in the staff relation is a valid one. Okay, so that's domain integrity. Entity integrity, to remember, that's just that the primary key cannot contain null values. So you are allowed to specify either a single attribute or some combination of attributes as the primary key, And once you do that, you must also make sure that each of those columns is declared as not null. That's on you. You have to make sure that you declare, in this case, client number and property number to be not null. Each relation can have only one primary key, so I couldn't have both of these primary keys in the same relation. This presumably would be two different relations. Also remember that you can have alternative keys. Those are keys that are unique but not chosen as the primary key. So you can indicate, in effect, that there is an alternative key by saying unique, and that says that, and again, it could be one or more attributes, and it enforces that constraint that either that attribute or that combination of attributes will have unique values. Okay, and again, if you declare it as unique, it must not be null. Any key must not be null, and why is that? Anyone have an idea? They have to be unique, right? If you had two nulls, they're not unique. Yes?
Do you have to include not null, or is that implicit?
No, you have to include not null. So if you say unique telephone number, then when you declare telephone number, you must say not null. I wish it were implied, but it's not. So you must explicitly do both.
Will it check to make sure the primary key is valid? Like it is the smallest set that can.
No, it will not. You could actually use a super key and it won't complain. Okay, referential integrity. So this is the way that you declare a foreign key and tell it which relation that foreign key is referencing. And you can have more than one, unlike a primary key, you can have more than one foreign key in a relation. In fact, you often do. Like the booking relation has more than one foreign key. It has room number, guest number, hotel number. It has 3 foreign keys. Okay, and again, a foreign key either references a valid value in another relation, or all of its fields are null, one or the other. But a foreign key can be null. Okay. Now, there is an issue if you have a foreign key. Let's say that I have I have staff that are in a branch. So in the staff, branch number is a foreign key. So it tells us which branch the staff member belongs to. What happens if I delete that branch from the branch relation? Okay, so let's say that I have staff S11 that's in branch 003, and that's in the staff relation. What happens if in the branch relation, in the branch relation I delete B003? Okay, if I do that and don't change anything, I violated referential integrity, right? So I have to be careful when I start deleting tuples that might have pointers to them. It's just like in C or C++, when we delete something and it has pointers to it, we don't want to leave dangling pointers, right? Same thing in a database, we don't want to leave dangling pointers. So there are 4 options for what to do when you delete a tuple in order to avoid creating a dangling pointer. One is no action, which is you reject the delete. As long as branch B003 has staff, you can't delete it. So that's one action that you can specify. So basically, you'll specify these on a foreign key and say what should happen. Okay? Or another one is the opposite, which is a cascade, which is if I delete the branch then I'll delete all staff tuples that are in that branch, which might lead to a further cascade because now I may have to delete all properties that are managed by that staff member or staff members. So it could ripple a long way through your database. So that could be pretty catastrophic, but that's an option. Okay, set null. You may simply set the foreign key to null. That's a nice way to do it. So you delete the branch, but we still have those staff members employed. We simply set their branch to null. And the fourth option is set default. Maybe there's some default value that it reverts to, such as the headquarters branch. Okay, so those are four alternatives that happen either when we update. So if we change the branch number from B3 to B5, we have to specify one of these four options. And then when we delete it, we have to specify one of these four options. Okay, so here, foreign key staff number references staff. On delete set null. So presumably, this first one might be for a property. Okay, if we fire the staff member, we don't want to delete the properties that the staff member manages. We still manage those properties. So in this case, we'd probably just set the realtor field to null to indicate right now that property doesn't have someone managing it. Okay, here, this is presumably on a property for rent. So if the owner pulls its property, so it says you're fired to Dream Homes and leaves, we probably want to cascade the updates because if the owner leaves, presumably all the properties we were managing for that owner also leave. So in this case, probably update cascade is right. Actually, this wasn't delete though. I guess it was on update, but it might very well be also on delete we would cascade it. Yes.
On the previous slide, you said that cascade deletes the row and matching rows.
Mm-hmm.
If you're doing on update cascade, does it actually delete the rows? Or
No, it updates them. Thank you. So on update, it updates it. So if I go from B003 to B005, it updates to B005. It's like if you move a piece of memory, it would be moving all the pointers with it to the new address. Garbage collection is like that. Okay. Yes, that's what happens. Okay, I still got a couple more minutes. I see a couple of you have to leave early, but it's not 1:55 yet. So I'll finish up with general constraints. So sometimes you have a constraint that's more, we had domain constraints just on a single attribute, but sometimes you want multiple attributes or you want an aggregation function. You can't use aggregation in a where clause. So there is also the ability to put the check command outside of a field definition. If you do that, you get the ability to also use aggregation. So here, we're writing a query that says that no realtor can manage more than 100 properties. So select staff number, group by, from property from rent, group by staff number, having count greater than 100. That returns some number of staff numbers. We want that to be the empty set, so we say not exists. If for some reason we insert a new tuple, and that means that the staff member now has 100 properties, that would violate the check constraint. Okay, just two more slides and we're done. So that you know this for the homework, some of these things are not supported in MySQL because it is public domain. So while they're in the SQL standard, create domain is not supported in MySQL at all. It will cause a syntax error. Check and foreign key are parsed, but not enforced. Okay? Hopefully someone in the future will donate their time and write the code to enforce it.
Forced up foreign keys?
Pardon?
Not enforced about foreign keys?
Nope.
Because
Least-
I can show you my SQL server that they're definitely enforced.
Okay, I don't think it's enforced on ours. At least it wasn't in the past.
It depends on which engine you're using. Actually,
Okay,
for my SQL.
right. Well, in the past it's not been on ours. I guess I haven't checked. Okay, enum is enforced, so you're allowed to enumerate. There's an enum keyword that's actually not part of the SQL standard that allows you to enumerate the types. So you're free to use these things in the homework too, but you can't necessarily test them. Okay? So I will see you Thursday. We'll finish up with DDL and get into the relational algebra and the relational calculus.